Hi Algebra 1B, this video is going to be on how you factor quadratic expressions where there is a coefficient. When I talk about coefficient, I mean a number in front of your x squared, y squared, whatever variable it is you're using. Now because of that coefficient, that actually changes a lot how we're going to factor these. The reason is this. When you think about factoring, because it's a quadratic and we've got that y squared y and a number, I know it's going to factor into two parentheses. What's going to be really different about this compared to what you've done in the past is in the past we've always been able to say, well, I know it's going to be y and a y, and there was just one pair of numbers we were looking for because that first term was just y squared. Our problem though here is because you've got that coefficient, it means instead of looking for just one pair of numbers, you're going to look for two. And it makes it more difficult. To get that 6y squared, I need to know, is it going to be a 1 and a 6 and a 1, a 2 and a 3 and a 2? We don't know. So I can't go ahead and fill in that yet. And then I know those last numbers are going to multiply to a 4, just like in the past. But again, I don't know what those numbers are going to be. Is it going to be a 1 and a 4, a 2 and a 2? I don't know. So I can't fill in anything else. Because there's two pairs of numbers we're looking for, there's going to be a couple steps we have to do before we can get to that final answer. The first step we're going to do for this problem is we are going to multiply this number and this number. When you compare it to the quadratic form, we say you're multiplying your A with your C. This first number with this last number. And when we do that, we get the number negative 24. Now this next part should seem similar to what we've done in the past. When we're looking at our negative 24, we want to find a pair of numbers that multiplies to negative 24 and combines to the middle number, combines to give us a 5. Just like I did in the past, I'll start writing out all the different combinations. I like to put mine in order, so I could say 1 times 24, 2 times 12, 3 times 8, 4 times 6, there's no 5, and then 6 is already on the list, so that helps me know I've got them all. Now remember, I'm looking for a pair of numbers that multiplies to give me negative 24. Now any of these could multiply to give me negative 24 if I put in a negative sign, but I'm also looking for the pair that could combine to give me that plus 5. And after looking at it for a moment, you might find that that pair we're going to use is going to be 3 and 8. I know if I have a negative 3 and a positive 8, I'm going to get rid of that multiplication sign. If I have a negative 3 and a positive 8, that could combine to give me 5. And if I have a negative 3 times positive 8, that would give me negative 24. Now this is where it's going to start to look different. We're used to these numbers being in our final answer. That's not what we're going to do this time. Instead, the next step we're going to take is we are going to use these two terms to rewrite the middle term. When I say rewrite, think of it kind of as like the opposite of combining like terms. So I'm going to change this one term to be two terms. And it helps that I've already put my signs here because that's going to be part of it. That 5y is going to change to be negative 3 plus 8. Now, negative 3 plus 8 gives me 5, not 5y. So I also need those y's there. Negative 3y plus 8y would give me 5y. I'm going to go ahead and copy down these other two terms here. I've got my 6y squared and that minus 4. So at this point, it just looks like we've made the problem more complicated, right? These are still equal to each other. All I've done is I've taken that middle term and I've changed it into two extra terms, so a total of 4 terms. That's the first part of this problem. Now the next part is going to be using greatest common factor, or GCF. That was what our first set of notes was on for factoring. It was factoring with GCF. Remember, that's when you're looking at 2 or more terms and seeing what they all have in common. So it's going to be the greatest number they all have in common, like the greatest number you can divide them all by, and then it also can include any variables they have in common. We are going to use greatest common factor for this problem here. We're going to split it into 2 separate problems. You're going to find the greatest common factor of these first 2 terms, And you're going to find the greatest common factor of these last two terms. Starting with the greatest common factor of the first two terms, I've got 6y squared minus 3y. Well, I know the greatest common factor of 6 and 3 is 3. So I can go ahead and put my 3 there. And because they both have y, y is also going to be a part of my GCF. Now, we saw in those first notes, when you're factoring with GCF, there's going to be a set of parentheses that comes after with what you would need to multiply 3y by to make all this. So 3y times 2 would get me the 6. I've already got a y, but I'm going to need one more y to get to y squared. And then for my second term, 3 times, well, I'll need a negative sign there to get to the negative. 3 times 1 gets me to 3. I already have a y, and I don't want any more y, so it's just going to be minus 1. So that's going to be our first part, is using GCF to factor those first two terms. If you're feeling good about this, if you want to go ahead and try that for these last two, you could pause the video now. If you are like, whoa, Samantha, this is way too soon, you haven't even finished the first example, that's fine. Just keep going along with me. I'm going to do the same thing again, though, for these last two terms. So right now we've got 8y minus 4. The greatest common factor of 8 and 4 is 4. So I'm going to go ahead and write plus 4. That plus sign is there. It goes back to that rule about like the sign of the first term. So remember, if that first term is positive, it means your GCF is positive. That first term had been negative, then the sign here would have been negative. But we've got our GCF is 4. Looking at this, they both don't have y, so y won't be a part of our greatest common factor. So I can go right into my parentheses. I know 4 times 2 gives me 8, and I know I'm going to need a y there, so I can get to 8y. And then 4 times, I'm going to need a negative sign to make it negative, and 4 times 1 gives me that 4, and then I can close my parentheses. So at this point, I have broken that middle term into two terms, kind of split it into like two separate problems and used GCF for both parts. And I got 3y times 2y minus 1, and then plus 4 times 2y minus 1. Now looking at this line here, do you notice anything unique about what I've just written? Maybe that's a weird question, or maybe you did actually notice that we've got 2y minus 1 both times. That is not a coincidence. If we've done everything correctly at this point, this should always happen. Because what we need for this very last part is we're going to need these to be the same. So if you get to this point and you don't see the same thing in parentheses, means go back and check the work above it. There's no point to keep going because something is off. But we should be very happy that we see that these are the same. For our last step, what we do is we say we're going to use GCF again. Looking at these two parts, again, I'm going to take out what they both have in common. And in this problem, what they both have in common is the 2y minus 1. So what I'm doing is I'm pulling this 2y minus 1 out to be my GCF. It's what they both have in common. Now, just like when we did that before, we pulled out what they had in common, and then we put parentheses around what was left over. So I've pulled out, they both have the 2y minus 1 in common. I'm going to put parentheses around what's left over. Well, for this first part, what was left over was that 3y. And for the second part, what was left over was that plus 4. And ta-da, look at that. That's what we're used to these answers looking like, right? We got two sets of parentheses. And what should happen is if we multiply all this out, it should give us what we started with. Now, you know I'm not going to stop there. We're going to go ahead and check it. And I'm going to check it very small so it fits here. So when we go to check, just like always, I'm going to multiply my 2y and 3y, which gives me 6y squared. My 2y times 4 gives me plus 8y. The negative 1 times 3y gives me the negative 3y. And then the negative 1 times the 4 gives me the negative 4. Now I just want to pause here for a second because I want you to compare this line with this line. The whole reason we were using these two numbers is because look right here. When you multiply it out, you end up getting a plus 8 and a minus 3, just like we did right here. They're just in the opposite order. And then if we finish our check, I'm going to combine these two, which ends up giving me 8 minus 3 gives me a positive 5y minus 4, just like we had in the original problem. I know this looks like a lot. It's because it is a lot. It's going to be the longest factoring problems we do in this unit, but I promise you, the more practice you do with this, just like a lot of things, the more confident you'll feel about it and the quicker you get at that. These problems some others teachers teach is just kind of like a guess and check. Like we were saying at the beginning, is we don't know if it's going to be a 2 and a 3, a 1 and a 6. We don't know which spot it goes in. Same with these numbers. We don't know if it's a 2 and a 2, a 4 and a 1. So you can do these kind of just like guessing and like playing around and moving numbers around and seeing what you finally need to make this. But I do like this process because it's a process. It tells you exactly the steps you need to take to get you to the right answer. So I know it looks crazy up here. I realize this. But I promise, the more practice you get with it, the better you'll feel. So speaking of practice, let me write another problem for us. And with this next problem, there's one other thing I'm going to want to talk about too. So the one we are going to look at is we're going to factor 5m squared minus 37m plus 14. Also, I made up more problems for this video, so these are different than the ones in the posted notes, just so you guys have a wide variety of examples to look at. But looking at this problem here, if we wanted to factor this, do you remember what the first step is going to be? We are going to start by multiplying our a with our c. So that's going to be the 5 times 14. When you do that, that gives you 70. What are we going to do with the 70? Ah, yes, you are correct. We are going to write factors of 70. So I can start by writing 1 times 70, 2 times 35, 3, 4, 5 times 14. Now, as you're going through your factors, as soon as you see a pair of numbers you think might be the pair that works, you don't have to keep going. So I kept going, but maybe you were like, oh, but wait, you've already found that pair of numbers. This 2 and 35 right here, I'm noticing, I'm trying to make a pair of numbers that multiplies to 70 and combines to 37. So when I wrote that down, because I had that 37 in the back of my head, I was like, oh, that may be the pair that works. So if I play around with the 2 and the 35 a little bit, I can see that if I make them both negative, negative 2 minus 35 would give me that negative 37 I want, and negative 2 times negative 35 give me that positive 70 I want. So I have found that combination of numbers. Now the next step, what are we going to do with that combination of numbers? Now remember, the next step isn't going into the parentheses quite yet. We use that combination of numbers for our middle term. We're going to rewrite our middle term. If you want to try real quick, see if you can figure out what it's going to look like. Pause the video if you need more time. But we are going to end up having that 5m squared that comes down. And using those signs I already figured out, I'm going to write minus 2m minus 35m. And then I'm going to copy my plus 14. Now, looking at this, our next step, do you remember what comes next? Is GCF. Remember, now that we have 4 terms here, we're going to split it into 2 parts. I'm going to find the GCF of these first 2 terms, and I'm going to find the GCF of these last 2 terms. Starting with the GCF of these first 2 terms, looking at 5 and 2, maybe you're like puzzled for a little bit because there really isn't a GCF. The GCF is just going to be 1, right? There's no number that goes into both of these. There's no number you can divide them both by except for 1. Now there is something they have in common though. They both have our variable m. So my GCF is going to be 1m, or we know we can just write m. I don't need to write the 1. And then parentheses around what I would need to multiply it by. That's going to be, for this first one, I need a 5, and I need another m to get m squared. And for our second part, I'm going to need a minus 2, but I don't need any more m's because I want 1, I already have 1, so I don't need any more. We can do that same thing for these second two terms. If you want to pause the video now, try it yourself. I strongly encourage that. Did you try? Maybe? Looking at these, our GCF of 35 and 14, it might take you a second to kind of think through it, but it's going to be the number 7. So my GCF is going to be 7. Now the part I'm curious if you did catch is, remember, if that first term is negative, what does that mean? Well, if that first term here is negative, it means that GCF is going to be negative. So I need to pull out a negative 7 from both of them. Notice I did not put m in my GCF because they both don't have m. So it's just the 7 they have in common. And when I go to see what I need to multiply that negative 7 by to make both of these terms, I would need a 5m, and then I would need a minus sign because negative times negative gives me positive. I would need a negative 2. So that negative 7 times negative 2 gives us that positive 14. Now looking at this, I'm super happy. Maybe you're happy at home too. Do you know why? I'm super happy because I see that we've got the same thing right here in parentheses. And remember we said in that last problem, that is what we want. We want this to be the same for our last step because our last step is saying they both have this in common. So I can pull that out as a GCF. I can say they both have 5m minus 2 in common. So let me pull that out to be my GCF. And then parentheses around what's left over. For this first part, it's that m. And for that second part, it is the minus 7. And there is our answer. Now, of course, I would recommend if you were doing this on your own at home, you would want to check all of this, multiply it out, make sure it gives you what we started with. Instead, though, I want to use this time to answer a question I've gotten before in the past. When we went to write right here, when we went to rewrite that negative 37m, I chose to write negative 2m and then negative 35m. And the question I've got, which I think is a really good question, is could you write negative 35m minus 2m and then your plus 14? Is that going to give you the same answer? Well, let's start with, can we write this? Could we write it? Remember, we're trying to rewrite this. We're not changing the amount. We're just changing the way it looks. So I was able to do this because negative 2m minus 35m gives you negative 37m. So if we change the order, that's okay because it still gives us this. Now what's going to happen, though, is we change the order when we go to do that next part and find our greatest common factor of the first two terms and the second two terms. It's going to change what your greatest common factor is. If I'm looking at 5m squared minus 35m now, I'm not going to have a GCF of 1. I'm now going to have a GCF of 5m. And in the parentheses, it would be m minus 7. And then same thing for the second part. If I've changed it to a 2 and a 14, I'm not going to have a GCF of 7 anymore. The GCF of 2 and 14 is going to be 2. And then in parentheses, I'm going to have m minus 7. So notice this line is going to be really different compared to this line if you change around the order. But the second part of that question is, does it give us the same answer? So I don't know. Let's keep going with it. Looking at this line here, just like before, I notice I've got something in common. We've got that m minus 7 in common. So just like we did before, we can go ahead and pull that out. I can say they both have m minus 7 in common. That could be our GCF. And then parentheses around what was left over. For this first term, we've got the 5m. And then the second term, we've got the minus 2. Now, looking at this at first glance, you might think it looks different. It's a different answer. But actually, notice we've got 5m minus 2, 5m minus 2. We've got m minus 7, m minus 7. So what does this mean? It means the order you put these in doesn't matter. Now, if you were working on this problem with a classmate or talking about it with someone and saying, I got to this part, but I got stuck, it's going to be important to notice if you guys have got these in the same order or not. Because if you've got them in a different order, you are going to have very different things. But it doesn't mean anyone's doing anything wrong. It's just a different way to do it. Math, there oftentimes actually are tons of different ways to do the same problem. And this is just an example of that. For this last part, I'm thinking, let me put one on the board. If you want to try it at home first, pause the video, try it on your own, and then resume the video to see if you got it right. I think that would be a good opportunity for you guys to practice this before you jump into the homework. So the one you're going to try is 8m squared plus 22m plus 5. Go ahead, pause the video now, try it, and then I will see you in a little bit. And right now it's a little bit. So, looking at this problem here, you should have started by multiplying your 8 and your 5 to get 40. When you list your factors of 40, I've got 1 times 40. I'm going to stop at 2 times 20 though, because I notice 2 times 20 is going to give me the 40, and 2 plus 20 gives me that 22m. We're going to now use the 2 and the 20 to rewrite that 22m. So it's going to become 8m squared plus 20m plus 2m plus 5. Now at this point, remember what we just said in that last example, if you've got these written in a different order, the next lines might look different for you. Don't stress, you could still have the right answer. It'll just look different depending on what order you wrote these two things in. If I keep going though with how I have it written, the greatest common factor of these first two terms is going to be 4m. That would leave us with 2m plus 5 in parentheses. And then for these last two terms, the greatest common factor is just 1. That's it. They have nothing in common. So then in parentheses, we're going to still have the same thing, the 2m plus 5. Our last step, they both have 2m plus 5 in common. So that becomes my greatest common factor. And then parentheses around what's left over. For the first part, that's the 4m. For the second part, that is the plus 1. If you had flipped these around the other way, you would just have 4m plus 1 and 2m plus 5, which is the same thing. Hopefully you found this video helpful. Like I said, I know this stuff is crazier looking, but I promise the more practice you get, the better you'll feel about it. The one last thing I want to kind of leave with in your mind is this long process is only if there's a coefficient there. So remember, there were some easier quadratics we looked at before this lesson. There was the factoring quadratics part 1, and then the factoring perfect squares, which was the part 2 of those notes. Don't forget that there is an easier way to factor some of these. You do not have to do this for every single quadratic. It's just when there's that coefficient there, that number in front of your x squared, m squared, or whatever it may be. Like I said, hopefully you found this video helpful. I miss you all so much. I hope you are doing well. Please feel free to reach out if you are struggling with this a little bit. I would be happy to help. And have a nice evening. Thanks. Bye.